This video is going to introduce you to some background information about matrices and how to use them on your calculator. So, for starters, what is a matrix? Well, a matrix is a way to organize numbers into rows and columns. Matrices are equivalent if they have the same dimension and if corresponding positions are equal. So basically, if they have the same rows and columns and the same number is in the same place, then we say the matrices are equal. So when you add and subtract, matrices must have the same dimension. This is a 2 rows by 2 columns, 2 rows by 2 columns. So these we can subtract. Basically, you are just going to take the first number in the first position, first row, first column, subtract the first number, first row, first column of the second matrix. So this is saying -2 minus -3, which is -2 plus 3, which is 1. -5 minus 4 is -5 plus -4, which is -9. 4 minus -3 is 7. 4 minus 6 is -2. And there you go. Number 2 is a 2 by 3, 2 rows, 3 columns. This is a 2 by 1, 2 rows, 1 column. These are not the same. This cannot be done. Multiplying by a scalar, really simple. You're just going to multiply the number on the outside to each of the numbers on the inside of the matrix. So -4 times 6, -24, -4 times 1/2, -2, -4 times 3, -4 times -2. Now, we can also multiply matrices, and this is tricky. I'm going to show you how to do this by hand once, but honestly, if our calculator will do it for us, I would just prefer to do it that way. It's a lot less complicated. So multiplying the number of columns in the first matrix must equal the number of rows in the second matrix. So let's say you have matrix A and it's m by n, and matrix B is n by p. These two numbers must be the same. If they're the same, then you may multiply the matrices together. If they're not, the problem cannot be done. So when these are the same, it's these other numbers that give you the dimension of the new matrix. Okay, so let's look at that. A 2 by 1 times a 1 by 3. Yes, those are the same. The resulting matrix has a dimension of a 2 by 3. 2 by 3, 2 by 3. Those are not the same. Those cannot be multiplied. Matrix multiplication is not commutative. This means we can't switch the order. Like this one here. If you did a 1 by 3 times a 2 by 1, notice all of a sudden those middle numbers are not the same anymore. Okay, so it's not like with regular numbers. 2 times 3 and 3 times 2 both give you 6. With matrices, it doesn't work that way. Alright, so here's how you do this by hand. It's really fun. Start off by figuring out the dimensions. The first one is a 3 by 2. The second one is a 2 by 2. These middle numbers are the same. Yay. That means that we will result with a 3 by 2. So then let's go ahead and draw that. That's what this is going to look like. Alright, so here's how we do this, and it is a little complicated. You're going to take the first row and the first column, first row of the first matrix, first column of the second matrix, and that becomes this location right here. First row, first column. And here's how we calculate that number. You're going to do the first number times the first number. 3 times 5 is 15, plus the second number times the second number. -1 times -1 is 1. Okay, and I'll add that in a little bit. All right, now we're going to do this one. This is still the first row, second column. Okay, so we're looking at first row, second column. 3 times 0 is 0, plus -1 times 3 is -3. Okay, next. Second row, we're going to do this one right here. Second row, first column. Second row, first column. 4 times 5 is 20, plus 7 times -1 is -7. Okay. Now we're going to do this one. Second row, this is in the second row, second column. Second row, second column. 4 times 0 is 0, plus 7 times 3 is 21. All right, so hopefully we're getting the hang of this now. So feel free to pause and try the last two places yourself and then check in with me. If you're still not quite sure, then I'm going to keep going. All right, last places, this is the third row, first column. Third row, first column. 2 times 5 is 10, plus 6 times -1, -6. Finally, third row, second column. 2 times 0 is 0, plus 6 times 3 is 18. Okay, and so then we just add everything up. And this is your final answer. All right, so that was just great. I know that was joyous. You really enjoyed that experience. But now we're going to do this with our calculator. So, really quickly, let's just make sure this can be done before we spend the time typing everything in. 2 by 2 and a 2 by 3. Yes, we should end up with a 2 by 3. So here's what we do. You're going to go to second matrix. You're going to go over to edit, and I'm going to edit matrix A. You can edit whichever ones you want. My first matrix is a 2 by 2. I'm just pressing enter, and then you literally just plug in your numbers and you press enter after each one. Okay. Then I go back to second matrix, go over to edit. Notice that matrix A is now filled in as a 2 by 2. I'm going to go to matrix B. Matrix B is my second one. That was a 2 by 3. Okay. Plug in your numbers, 6, 1, -2. And again, I'm getting these numbers from these guys right here. 3, -1, 5. All right, so the nice thing about this, I'm going to go ahead and quit out of this, is that there's zero computation. Your calculator does it all for you. Second matrix. Don't go to edit this time. Just press enter. And you can press the times button, but honestly, you don't even need to. Second matrix B. And ta-da! The cool thing is, if you get a decimal, you can even math frac this and turn it into fractions. All right, so -12 and 18, -5, -3, 16, and 18. And there you go. So you can check the one we just did by hand if you'd like. You're never going to have to multiply this by hand in class. We're just going to use your calculator. Okay. All right, a couple more things we got to talk about. Identity and inverse matrices. The identity matrix is always a square matrix, a 2 by 2, a 3 by 3, a 4 by 4, etc., etc. The identity looks like this. It has 1s on the diagonals. Okay, and what happens is when you multiply any matrix by its identity, you end up getting the same thing. So these have to be square matrices though, otherwise it won't work with our laws of multiplication. So this matrix right here, we're going to multiply it by the 2 by 2 identity. Let's plug that in, second matrix. I'm going to go to edit. I'm just going to replace matrix A because it's already a 2 by 2. 5, 3, 2, 4. 5, 3, 2, 4. Okay, now I'm going to go to second matrix again. I'm going to go over to edit, and I'm going to edit. I'm going to do matrix C this time. 2 by 2. 1, 0, 0, 1. And now I'm just going to multiply these together. Second matrix A, second matrix C, and you do get that 5, 3, 2, 4, which is what we had to start with. You can also reverse it because they're both 2 by 2s. When you flip them, you still have the same numbers in the middle. Okay, so there you go. Now, multiplying the matrix's inverse takes us back to the identity matrix. We're going to use this a lot this chapter. It's used to solve complex matrix equations to undo multiplication. When we're multiplying matrices, we cannot divide out matrices. It doesn't work that way. Instead, we use the inverse. So, calculate A inverse from example 6. So in order to do this, it's actually not as complicated as it sounds because literally you have an inverse button on your calculator. So hopefully you still have matrix A in your calculator. You're just going to go second matrix A. And then the inverse button is the one you've been using with the matrix. It's that guy right there. Just click that. And you get this. And you're like, oh, that looks awful. So let's math frac that. And it still doesn't look fantastic, but there you go. So what we're just going to show is that when you multiply this by matrix A, you get back to the identity. So just press the times button, and let's go back and grab matrix A again. And enter, and it gets you back to the identity. Ta-da! Okay, I don't feel like writing that whole thing down, but you can go ahead and do so. So now what we're going to use this for, again, is to solve a matrix equation. Okay, we are going to do number 8 and 9, and then we're done with this video. This is something, again, that's really important. It's going to save time for us a lot. So this is matrix A. This is matrix B. In order to do this, to solve for x is going to be A inverse B. So you're going to type matrix A and matrix B into your calculator, and then we're going to just use the inverse button. Let's give it a try. First, you got to get them typed in. So that means you're going over to edit. This is a 2 by 2, -3, 4, 5, -7. Go back to second matrix. Go back to edit, and I'm going to just do C again. Well, I'll do B because that's the letter we used. Change your dimensions. And matrix B is 3, 8, 2, and -2. All right, so now all you're doing is A inverse B. Get your matrix A. Press the inverse button, get your matrix B. Press enter. And what you've just solved for is the matrix that when multiplied by A yields B. So -29, -48, -21, -34. And there you go. That's your answer. This last one is going to be exactly the same. The difference, though, is that you are going to have to subtract over this 8, 5, 1, 15 first. So it's just going to be like regular subtraction. 7 minus 8, negative 3 minus 5, negative 2 minus 1, negative 9 minus 15. All right, so go ahead and start typing those into your calculator. Second matrix. So both are 2 by 2s again. 3, 7, 1, 4. Second matrix, over to edit. And our new matrix is negative 1, negative 8, negative 3, and negative 24. And again, we're always going to write this x equals A inverse B. Second matrix, A, inverse button, second matrix. Oh boy, that's not what I wanted. Let's try that again. Second matrix A, inverse, second matrix B. And you get this. And again, if you'd like, you can math frac that. And wow, there's your answer. A very large answer. I'm not sure why it decided to make it that big. There you go. It's a little squished, but that's what you should get. The decimal is fine since it's not repeating, or the fraction. Okay, so there you go. Hopefully this was helpful to you and you super love doing these on your calculator and not by hand. Have a great day.